All right, now that we've done 2 horizontal circle problems, let's do a couple vertical circle problems. So I have here a car that is at point A traveling with a constant speed, but then as he goes up over hill B, he's going to start to have an acceleration because he's moving in a circle. And then at point C, he's down at the bottom of the hill. As you can see, I've outlined where those vertical circles are based on the hill and the dip. Both of the circles have a radius of 10 meters. What I would like to find out is at what speed does the driver need to move at point B so that the driver feels weightless. Now that is code in physics talk for Fn to equal 0 newtons. Because Fn is your apparent weight. It's how much you feel. And so if you want to feel weightless, then you would want your weight to feel as if it was 0. Okay? So here's how we do that. First and foremost, we should draw free body diagrams and all of our cars for right now. So for A, FG is always going to point down, and because that's a horizontal surface, Fn is going to point directly perpendicular to the surface. At point B, I have FG, which is pointed down, and Fn, which is pointed up. And at point C, I have Fn perpendicular to the surface, and FG straight down. Okay? Now, at point B, what speed the driver will feel weightless, this is forces. And so I've got F net equals MAC because up I'm moving in a circle, and F net is my helping minus my hindering forces. Now if you remember, when you're moving in a circle, helping forces point inward and hindering forces point out. So my helping force at point B is Fg, and my hindering force is Fn. And that's going to equal mv squared over r. Now, again, I want the driver to feel weightless, which tells me Fn should be 0. So I'm going to turn that into a 0 term. So Fg is mg equals mv squared over r, and I want to solve for v. So I'm going to divide by m, and because there's an m over here, they're going to drop out, and I'm going to multiply by r. So I get v squared is equal to r times g, or v is equal to the square root of rg. So that would give me a speed is equal to the square root of 10 times 9.8, which is equal to 10 times 9.8, and the square root of 98, which is 9.89 or 9.9 meters per second. Okay? Excellent. Now, what about at point C? If the car is still traveling there with the same speed, how much heavier are they going to feel there? How heavy? That's code for what is the Fn. And so when I look at this circle, oh, something's changed here. My helping forces point inward, and that's my normal force. My hindering forces point outward, and that's gravity. So now I'm stuck here with F net equals MAC because I'm moving in a circle, and my helping force now is the normal force minus gravity equals mv squared over r. So Fn is what I want to solve for, and I've got that equal to mv squared over r plus mg. Now I'm going to need a mass for my person. So let's say that that mass of the person here is 60 kilograms. Okay? And let's figure out what their normal force is. 60. Remember, my speed is going to be the same speed where they felt weightless. So that's the one from at point B. So that's 9.89 squared all over 10 meters plus 60 times 9.8. So 9.89 squared divided by 10 times 60. This is 586.8 newtons plus 60 times 9.8. That's 588 newtons. So those added together leave me with a normal force of 174.8 newtons. Oops, sorry, 144.78 newtons. So how does that compare when they're traveling on a horizontal surface? Well, on a horizontal surface, Fn is equal to Fg, which means my Fn is equal to mg. And well, mg is this, 588. So Fn is equal to 588 newtons. So how does that compare? Is that larger? Is that smaller? That's much larger by this particular factor. So you could figure out the ratio by dividing the two. And that's your vertical circle problem. So if you wanted to determine the ratio between how heavy you feel at point C versus how heavy you feel at point A, you would put the number of newtons at point C over the number of newtons at point A, and you would come out with about twice your normal weight. And that's how you would figure out how much more you would weigh, about twice your normal weight.